9, 8, 7, 6, 5, 4, 3, 2, 1.
Welcome! You made it! Hello, everyone! Hey, my name is Stefano. I'm here at Science World right here at Science World, and welcome to the Earth Day 2023 live stream with BC Hydro and Science World. It is a pleasure to have you here with us, and it's exciting. For those of you joining us from far, far away, I want you to get involved, be on that chat. We've got lots of fun today, and I'm really excited. So here's the deal. Earth Day is not until this coming Saturday, April 22nd. But we're getting a little bit ahead of it so we can be prepared. And our global theme this year is it's invest in our planet. So today we're going to focus on investing our time and energy exploring ways to support our planet. So we can do that by, well, learning about Earth systems and the challenges facing our Earth, like climate change. Also, we can learn how we can be responsible with our natural resources through renewable energy and efficiency. All right. Now, we know that real progress to these global challenges need practical, step-by-step guidance. So we will give you some great resources and learn to take action together in meaningful ways. And we're going to do that with some fun demos and some fun friends today. Are you ready? All right. Before I start the presentation, I also want to acknowledge that we're here at Science World in Vancouver, and this area is also the traditional and unceded territory of the Musqueam, Squamish, and Tsleil-Waututh First Nations. They've been stewards of this land for years and years, and continue to be so with us. This is, in fact, what it used to look like a long time ago, and it's changed a little bit over the years. Now, I hope you've gotten to the chat there and been able to put a little bit of something in there. Here's what I'm going to do. I'm going to encourage you to show us where you are joining from, what land, what place you are. Here's us on the globe, on our planet here, with that little dome down below. And in the chat, you can mention the city you're from, or the name of the school you might be watching from, or even the classroom teacher if you'd like. That's great. So let us know. We'll do some shout outs throughout the show. You also might have some questions throughout. We love questions at Science World, so feel free to put questions in the chat. And my friend Larry, who's helping me with all the tech today, fantastic. Thanks, Larry. That's really excellent. We'll take some of those questions, and we'll answer them together. All right, let's see what we have to do next here. Well, you know, it's also Thursday today. So I'm going to do a little bit of a throwback Thursday theme on our presentations today. So you're going to see some things from times past. And getting back to our friends that were joining us today, you out there in the chat, but also our friends from BC Hydro. So let me introduce my friend Elias. Hey, Elias.
Hi, Steph. Hi, everyone. Happy to be here today. Excited for the Earth Day live stream.
You've got lots of fun stuff up your sleeve, I know. But I'm going to kick us off with a little bit of a discussion here, and I'll come right back to you. All right, Elias?
That sounds great to me.
Awesome. Larry, anybody on the chat letting us know where they're joining us from yet today? Miss McNeil's grade 2-3 class, welcome. That's fantastic. Big shout out. Yeah, amazing.
Surrey, BC,
Port Hardy, Surrey. View Royal. Hey, we were out there recently. Fantastic. We get all over the province, not virtually, but in person.
Whitehorse in Yukon.
We've got some folks joining us from Whitehorse in Yukon. Amazing. Well, this is the beauty of digital, and the beauty of the fact that we're celebrating the planet. We're all on the same planet. We're just in different places today, and we're all joined here. Fantastic. Now, I mentioned about some of the themes, and I mentioned energy as one of the themes today. And now here's the deal. Energy doesn't just appear, does it, Elias?
Well, not necessarily.
Yeah, it can be converted from one form to another. We often convert it into electrical energy so we can power things we need, like light bulbs that help us see, or electricity to help us run this live stream right now. So in the chat, if you can put the kind of energy you think that humans can convert into electricity, just put that on in the chat. We want to find out what you think. I'll start with one example. Pizza. Pizza? Yeah, pizza. It's the chemical energy that gives me energy to move and, well, to do this live stream. All right, so here's the deal. Let's get some chat results. In the meantime, I'm going to set up with a really neat demo here. I'm going to show you something fun. Okay. All right, so I'm just going to put this So what I've got here, folks, find out what kind of energy you're using. What is this, Stefano? What has he got here? There we go.
Is that a pickle?
It is. Can I get a wide shot on that, Larry? Thank you. Excellent. Oh, there. Stay. Okay. So what I've got here, speaking of pizza, I've got another food energy. Larry, at any time you can interrupt us and let us know what other people use to power their light bulbs or other devices, or where they think they can convert energy. I'm going to take this pickle right here, and I'm actually going to run some electricity through it and use it as a light bulb. Does that sound like pretty fun stuff? Oh, yeah. I see some answers on the chat. I see my grade 3-4's answer is water. Yeah, water is definitely one of them. We'll definitely cover that today. And a big hello to the various classes. Oh, macaroni and cheese. Yeah, just like the pizza. Great answers. Thanks, Rebecca H. All right. Pickle. Yeah, Lucas, we're doing the pickle. That's what we're doing right now. All right, so here's what I'm going to do. I'm going to turn on my machine, make sure everything's plugged in correctly. And I'm going to be running this electricity from the wall into my pickle. And we're going to see if we can turn our pickle into a light bulb. I did promise some electrifying excitement here. I've got a dimmer switch to my left here. I'm going to turn it on. So I want you to look carefully at my pickle and see if I can light it up. Are you all ready? Oh, yeah. I see that there's a lot of, oh, look at that. Solar energy to heat our house. I love these answers. Fantastic. Energy drinks, potatoes. Amazing. All right, here comes my amazing demo. Here we go. A little bit of energy coming through. See what you see. We're going to change it from electrical to something else. Oh, I should probably put my goggles on. Prepared. Don't want any pickle juice hitting me here. There we go. Ready? Good. There we go. Turn the switch on. Power's up. Plug in. And more juice. Oh. Oh. Wow, my dimmer's at maximum. So this is all the power coming out of the wall. And there it is. Pickle light bulb, everyone. Yahoo! Yeah, so cool. Thanks, Lucas. That's amazing. And hi, Bear Creek Elementary in Surrey. Now, this pickle light bulb is actually emitting heat. And also, if I just give it a burnt smell here, it's actually heating it up a little bit. So I've got light energy and heat energy, which is cooking my pickle a little bit, which is making not the best smell in the studio right now. Elias, what do you think of this demonstration?
Well, Steph, I gotta say the pickle light bulb is pretty cool, but it's not really the most efficient way to light your home, I'd say.
You're not wrong. You're not wrong.
Well, it might be difficult to light up your entire house with pickles, Steph. Not only that, but I'm not even sure a pickle is an efficient source of lighting. What I do know is that LEDs, which stand for light-emitting diodes, are the most efficient lighting technologies. When comparing LEDs to an older lighting technology like an incandescent bulb, Energy Star LEDs are at least 75% more efficient than incandescent bulbs.
Hang on. Did you say 75% more efficient than the incandescent old-fashioned ones?
That is right.
3/4. That's some fast math.
More.
That's a lot.
That's a lot. And by replacing an incandescent bulb with an LED, you can actually save $75 in electricity over the lifetime of an LED bulb.
It's another incentive.
Yeah. And because LEDs can last up to 10 to 15 years, you won't have to replace bulbs nearly as often.
That's very cool. All right. So
there's some environmental, aspects when it comes to the bulb, because you might have, say, an incandescent bulb and you want to replace it with an LED, but you already say have a lot of incandescence, right?
Yeah. So if I just want to leave the one and let it finish its life and then replace it, that's not a good choice?
Well, actually, from an environmental perspective, if you factor in the energy wasted to power an incandescent bulb compared to an LED, it's actually less wasteful to toss a still functioning incandescent bulb than to wait for it to burn out. So in that sense, it's more worthwhile to actually switch it sooner than you can.
Wow, that's all you said, 75%. So that's a big difference. Yeah.
Yeah. Well, actually, Steph, I have a really cool way of demonstrating how much more efficient LED bulbs are compared to incandescent bulbs. It's kind of a fun experiment / game. I don't know if you're interested.
I love it. Hey, let's see out in the chat. We've got Fort Langley, Bear Creek Elementary. We've got lots of folks in there that are excited. Let me know if you want a fun demo from BC Hydro. I certainly do. My pickle demo was pretty cool, but I have a feeling Elias has got something fun for us.
The pickle demo is pretty cool, but you can follow me this way, Steph.
All right.
I can show you the experiment that we have. So if you look behind me here, we have our BC Hydro powered by water bicycles. Very cool. Now, powered by water is a pretty common phrase we use at BC Hydro to describe our system, as over 98% of the power we generate is from clean, renewable sources.
Okay.
Steph, did you want to race on our bikes to really illustrate the differences? in
Yes,
LED
yes,
and incandescent?
yes, absolutely. These look pretty cool, and I want to get on this and try this out.
They are pretty cool. Now, for this activity, we obviously have a blue bike and we have a green bike behind me. And as we're pedaling on the bikes, the energy we create from pedaling will actually help light up the towers.
Mm-hmm.
So the green bike behind me is attached to an LED light tower, and the blue bike is attached to an incandescent light tower. Now, for reference, Steph, do you mind showing everyone what an example of each light bulb might actually look like?
Absolutely. All right, so folks, this is an old-fashioned light bulb called incandescent, and this one is an LED, which is, what was the word for LED?
Light emitting diode.
Light emitting diode. We're learning stuff.
Pretty cool, right? Now, before we get into the race, we're gonna use our pedal power, similar to the turbines being powered at our hydroelectric dams, to power each respective light tower. So as we're pedaling, Steph, I want you to imagine that you are a part of the process of creating hydroelectricity. At our hydroelectric dams, there is potential energy stored in a water reservoir behind the dam. That potential energy is converted to kinetic energy when the water starts flowing down the penstock from the dam.
Hang on. So that's like I'm part of the generation, like the penstock would be like the bicycle wheel and all the turning, generating. So what we're doing here is transferring my physical kinetic energy into electricity like a hydro dam.
Bingo.
So
in this sense, you're converting that potential energy to the kinetic. Exactly. So that falling water from the penstock strikes a series of blades attached around the shaft, which converts that kinetic energy to mechanical energy and causes that turbine to rotate. Now, we'll show you more about how these turbines operate later on in the program. When that turbine turns, the generator converts the turbine's mechanical energy into electrical energy, similar to how we'll be lighting up the lights on the bike and on the tower. So the rules of the game are pretty simple. The first to fully light up their tower wins the challenge.
All right.
Are you ready?
I am so ready. I'm going to win this race.
All right.
Hey, all of you in the chat, if you're, hang on, I'm just going to say a quick hello to them. All right, so all of you in the chat, can you see me all right? Yeah, okay. So you're going to cheer for Stefano here, okay? You're going to cheer for old man Stefano, okay? Or Elias, if you'd like. We're going to see if who's going to win this race. All right.
All right. So here's what you're going to do. You're going to have a seat on the bike.
Got it.
You're attached to the blue light tower. That's the incandescent light bulb tower. I have the LED light bulb tower. So what we're going to do is we're going to slowly pedal the bike to turn on the lights and get the system going. And essentially on a count of 3, 3, 2, 1, go, we can start pedaling. And whoever lights up their bulbs all the way to the top first is the winner.
All right, I'm going to light all my bulbs to the top and I'm going to win. Here we go.
We'll see about that.
Let's
All right.
start to turn it on.
The charge.
There,
You'll see them turn on.
Okay, now.
3, 2, 1, go. Looks like mine is already starting a little bit.
Hang on, that's not fair.
I'll give you a little catch-up time.
All right, that's starting charged up, okay, and I'm going to start pedaling.
You can feel free to pedal.
Look, hey!
It looks like my bike is a little bit more efficient than Steph's. Now, we can let Steph do his thing and try to charge his light towers there. But as we learned earlier, LED bulbs are 75% more efficient than incandescent bulbs, which is the reason why Steph over there is still struggling to light up his tower, while my LED tower was lighting up much quicker. So one of the reasons why those older style incandescent bulbs are so inefficient is because they typically create a lot of heat when they're on for periods of time. You may have experienced grabbing a light bulb that's been turned on for some time and feeling some of that wasted heat if you've ever seen an incandescent bulb before. That heat that's created from incandescent light bulbs is wasted energy because at the end of the day, we're using our light bulbs to create light and not heat.
Oh my goodness, that was so much work. I think I created a lot of heat.
You did.
Not as much light.
Not as much success creating the light, but that's okay, right?
Okay, oh my goodness, that's a really good point. So that one took a lot more energy. I can vouch for that. Yours is very efficient.
Yeah, my tower did seem a little bit more efficient.
Now, you might in your homes not be sure what's efficient, what's not efficient. So luckily, we've got a place for that. You can look that up. And you can look right now in your classrooms, in your homes, wherever you may be on this beautiful planet, and look around and go, I wonder if this is more efficient than that. Now, you can obviously look for LEDs or incandescent bulbs, as we've described, or you can check different devices and think about which one you think is more energy resourceful or resilient. I can't even.
Yeah, well, you can compare what's more energy efficient from one appliance or one light bulb to another. I don't think they have pickles on there, though. So
I don't think pickles is on the chart.
That's one thing you won't be able to
We're
check.
popping it in the chat so you can use that resource at BC Hydro's website to figure out. I mean, I think a lot of gaming stations are actually.
They are, yeah. I know they have some gaming systems on there to check out if anyone's curious to see how much energy that's using.
Well, now, this is the thing. Keeping up your technology up to date is really important. I'm going to go back to my chair. I'll meet you there in a second. Okay, I'm here. Hi. So, keeping up your technology, making it useful and resourceful, and sorry, I can't talk. Wow, I should just bite more. Making it more efficient is very important. We've been doing this at Science World lately a lot. We've been doing a big renovation project, and actually, I happen to have here a couple of lights that we've removed from our dome. Now, I'm going to show you these and talk about them in a second, but I want to do a Throwback Thursday right now. So, back in 2020, we did a team up with BC Hydro, and we did a live stream where we went up on the roof. I'm going to do a quick throwback, show you what it looks like up on the roof to see these lights that I just showed you in action. Hey, Larry, can we cut to Brian, throwback to that live stream we did in 2020?
Hi, everybody. Welcome to Science World. My name is Brian. We are so excited you can join us tonight for electricity and winter safety. Now, something I love about winter, it gets darker so much sooner, so you can put amazing lights up around your house. You can decorate things. We do that all year round. If you want to see, this is actually what one of these lights up on the Science World Dome looks like all through the year. Now, these lights up here, it might look like a Zoom background, but I am actually here on the roof of Science World with you right now. We can change the color of these lights, but I thought it would be fun to try a little sparkly pattern today. So, I have a little computer here, my iPad, that can control and program all of the lights on the dome. And with your help, we're going to get something a little bit spectacular to start the show off. So put some emojis, type some things in there, throw some comments on, show your excitement as we build up here, because we're getting ready to start our electricity and winter safety show. Check it out. I'll see you downstairs. Enjoy the show.
Well, that was Brian.
Hi, everybody. Welcome to...
Oh, that was Brian back in 2020. So if you do actually want to enjoy that show, you can go to Science World's YouTube page and you can watch the rest of that presentation. We like to keep those on our page so you can enjoy all kinds of programming throughout the year, anytime. Now, those were showing some of the technologies that we've upgraded. So this is the one that Brian had right here on the dome, and he didn't show you these. These are the flashing strobes that were on the top. These strobes are very inefficient, and so we replaced all of them over the course of this last little while. This is still work in progress, and we're replacing these ones as well. So we'll have a better, more efficient system overall and have a lot more ability to show different lights on the dome. So that's what's actually happening. Pretty cool light bulbs, huh? Look at that. I should give one of those away as a prize. It's pretty sweet. Now, a lot of questions come up about what we're doing, not just at Science World, but around BC. And a little throwback to a couple days ago, we're doing a series called Ask Science Worlder. So I'm going to show you our answer to a question that we got asked recently. By the way, in the chat, I see a lot of excellent things going on. Keep adding questions, keep doing things. Let's find out how we answer the question somebody asked us on the street.
Hey, do you have a question for Science World?
Yeah, it's kind of general, but what is this province doing to reduce its greenhouse gas emissions?
Stefano, do you have that question?
Yeah, excellent question. And I have just the friend who could help me answer it. Hey, Elias.
Hi, my name is Elias and I work at BC Hydro. While 98% of the power we generate at BC Hydro comes from clean and renewable resources, nearly 70% of the energy used by people in BC is still provided by fossil fuels, which produce greenhouse gas emissions and contribute to climate change. The province is incentivizing the use of heat pumps for both homes and businesses. This energy-efficient technology moves warm air outside in the summer and brings in warm air in the winter. The province is supporting more electric transportations by installing electric vehicle chargers across BC and offering rebates for electric vehicles. You can also reduce your emissions by taking a bus, walking, or riding a bike.
Thanks. Hey, thanks for asking that question. You know, answering questions is a great way to learn from each other and make a great network of people. And the more network of people we have that care, the more we can put an end to climate change by working together. Thanks. That's it. Cool, right? Working together. It sounds like a lot is happening in BC to improve sustainability and to help our planet. In fact, we have a climate hub on our website called Change Reaction, and we'll pop that. There it is. But it's a place you can visit on Earth Day, well, today, tomorrow, on Earth Day, and beyond, to explore the unfolding science and timeless solutions for regenerating our planet. It's also a great classroom resource for climate change. I happen to know also that, Elias, at BC Hydro, you have some resources for teachers and people as well, don't you?
Yes, Steph, we do. So we have our schools.bchydro.com website, as well as our Take Action Earth Day activities that we have. So classrooms that take part in our BC Hydro Earth Day activities will actually be entered to win a prize package to help their sustainability commitment. And this prize package actually includes a biodegradable sprout pencils that can grow into plants,
Cool.
eco-friendly wildflower seed kits, and even a visit from Science World and BC Hydro. Now, the Earth Day activities are ending in a couple of days. You have until Saturday to enter into that prize package. So be sure to check it out.
All right, so classrooms, that's right. Elias says that if you want to enter that contest, just follow the links and we'll put them in the chat here. And if you enter, then you can win a bunch of cool stuff, including a visit from the two of us in person. It might not be the two of us exactly, but maybe. As we said in the video, awareness and community are super important to help amplify our efforts. Can't do this alone, folks. We need everybody to be on the same page, right? And when we build a network of people who care, we are able to do much more. Now, Science World and BC Hydro working together today. We've been working together on that video. And in fact, right at this moment, I have got my team and the BC Hydro team in Fort St. John doing shows in schools in person. There they are right there. There's Karen, Emma, Tom, and Russell doing their thing in front of a school right there. And they are presenting science shows up there. And this relationship has happened today, and it's been going on for a long time. Hey, Russell, I got a surprise. Elias, I got a surprise for you.
Yeah.
We went deep into the archives for this Throwback Thursday. We're going way back. We've got a clip from when we used to do this. I'm going to say it, in the olden days.
Okay.
All right, so this is a Throwback Thursday from 1991. There's our plasma ball in a gym at a school, like my team is doing right now, and there's a bulb that's being lit by those kids holding hands. What? Wait, what is this?
Are those bikes?
Those are absolutely the 1991 version. What I just got exhausted on. This kid's got a lot more stamina than I do, I'll tell you that. Look at that. So they're lighting up light bulbs, probably not using the LEDs, because in 1991, we wouldn't have had those yet, right? Look at that. And so using their kinetic energy, look at this great person from BC Hydro explaining it. Throwback to 1991. Wow.
1991. I wasn't even born yet in 1991. Were you, Steph?
Well, yes. Yes, I was. I was probably listening to Milli Vanilli at the time. I'll leave that with you. Girl, you know it's true.
I'll do some research.
You can blame it on the rain if you like. I'm just saying. Yeah, it's a throwback. And 1991 was a long time ago. Speaking of birthdays and how old people are, if you are celebrating a birthday today, let us know in the chat. Lucas, I'm going to do a shout out to you. You've been really great in writing some great stuff in the chat. How long did it take to make the LED bike? Well, apparently they've been prototyping it since the 90s. Is the answer to that. But if you have a birthday today, put it in the chat, and we'll do a quick shout out, because birthdays are a great way that I like to use to explain the difference between weather and climate. Remember we said we were going to cover that earlier? That's now. So the difference between weather and climate is that weather is basically what's happening outside. So like cloudy, rainy, yeah. So if on your birthday today it's cloudy, rainy, that's weather. But climate is more about how each birthday would have had a different weather on it. So if you were born in, say, 1991, that's a lot of birthdays. So if you might have noticed the weather might be rainy, 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 rainy every single birthday, which probably means you live in Vancouver. And also you might notice a change in the pattern. So climate is that weather over all those birthdays, and climate change is a change in that pattern. So maybe sunny, 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 rainy, 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 rainy. And that's about as simple as it is for those of us born in 1991 or more recently than that. Now, speaking of, let's see here, climate, this. Oh, you know what? The climate question is a little bit complicated. And I have a friend of mine who at Science World here that can help us get a little bit of a deeper dive. She's up in the park. Let's go say hi to Kristen.
Good girl, Zoe. Hey, I'm wondering, do you have a question for a scientist?
Yeah. What exactly is climate change?
Kristen, do you have that question?
Yeah, so I'm Kristen. I'm the summer camp manager here at Science World. We're actually learning about climate change in our gardens. Now, if you're asking about climate change, it's a long-term shift of weather patterns caused by our increasing global temperatures. If you take a look at our hoop house here at the gardens, this has a really thick vinyl cover. Imagine the vinyl cover is the heat trapping gases in our atmosphere. So the thicker the cover, the more carbon dioxide, the hotter the earth is. Now we're actually building a hub called Change Reaction, and it has cool stories and concepts to help people kind of understand climate change. So if you want to find out more, check out our website.
Thanks, Kristen. That is a great reminder and a great way to explain that. Thank you. Before I go any further, I just want to say a big shout out and birthday wishes to Mila at View Royal, as well as Will. Apparently, Lucas Will has got a birthday going on, and I believe Jessica's birthday is in 2 days, which means that they'll be celebrating on Earth Day. Happy birthday. Now, as Kristen said, you want to check out our Climate Hub, which is scienceworld.ca/change reaction. There's a Climate 101 section that you can use as a teacher, as an adult, as a kid, and you can dig a little deeper. See, here's the deal. Weather is affected by the sun, the water, and all the atmosphere, that air around us. The air in our atmosphere that surrounds the Earth. Let's get the Earth, hang on. There it is. The air that surrounds the Earth is called our atmosphere. Does anybody in the chat know what kinds of air, what makes up the air that's in our atmosphere? I'm going to give you a hint. 2 of them are happening right now with my body. All right, put those in the chat. What you think makes up our atmosphere. All right, I'm going to put this down for a second here. So this dome here, this globe here, is our planet is sort of extends because that affects the planet on top. Now, in the chat, I'm seeing some answers coming up, but I'll just tell you the scientific answer is that around 80%, so 4 out of my 5 fingers here, is nitrogen. About 20% is sort of my thumb, is oxygen, and trace amounts of other gases and water vapor fulfill the rest of that average percentage. So most of what's going around is not, for example, carbon dioxide, which is something I'm exhaling right now. But carbon dioxide is one that's really worth talking about because it is a heat trapping gas. Kristen mentioned a bit of it. Now, when people use fossil fuels like oil for energy or gasoline in a car, we pump more and more of that carbon dioxide. Oh, look at that, Deanna, oxygen, nitrogen, and carbon dioxide. Excellent. Nitrogen, Rebecca, really nice, really nice. Ms. Chapelski's class said nitrogen. That's awesome answers. Sorry, I got distracted by all your awesome answers. I was just saying how when we pump more of that carbon dioxide into the atmosphere, that actually creates a bit of a blanket here, like this, right? And the additional heat that humans have added over our atmosphere, keep adding it more and more and more and more, making our planet warmer. A little too cozy there, right? And that additional heat that humans have added in our atmosphere causes that climate change. Now, on land, climate change is making our summers drier and hotter and our winters warmer and wetter. Here in Vancouver, for example, we're noticing things like the heat dome, additional flooding from glaciers and snowpacks melting quicker. And that is not cool. It's hard. It's hard to be in this environment with that way. We want to kind of avoid that. Now, speaking of water, I just mentioned, in the ocean, climate change makes the water warmer and more acidic, which you can imagine is maybe not good for the ocean. Now, here's an example here. I've got some of that water right here. And if I was just to take here, I'll do a little one. If I was just to take some of that water and exhale some of my carbon dioxide, bubbles, but not really a visible change. In fact, it's very little carbon dioxide coming out of my breath. But I happen to have something very cool with me at Science World. I happen to have some dry ice, which is also carbon dioxide. It's just in solid form. It's so cold that it's solid. Look at that. This is a gas. So it's warm enough in the room. It's melting. Sorry, it's sublimating and turning into a gas. Look at that. So if I drop that into our liquid, there's more carbon dioxide. Let's see what happens. Ready? Ready for this? Oh, methane is also true, Mrs. Hunter. There's not that much of it. There we go. All right, so there we are. It is bubbling up. And look, some of that gas is now released. We can actually see it in this form. Now, carbon dioxide is really a real cool thing. Carbon dioxide is very, it's heavier than the air in the room. I actually pour out the carbon dioxide. Look at that falling down. Now, though that looks cool and is fun to watch, what I'm doing here is actually adding more carbon dioxide into my lab. And it's not dangerous, but it is not exactly what we want to be doing. But you can't really see what's happening in the water. So I've got this liquid right here. I've got a chemical called bromothymol blue, which tells me if there's an acid present. And this is what I meant about oceans acidifying. So if the ocean gets more acidic, that's not good for the plant and animal life in the ocean. So here's an example now, putting some of that carbon dioxide so we can see more tangibly what happens if there's a change in our water when we add it. Now, because that chemical will tell us that there's carbonic acid created. Here we go. Ready? Plunk. Put another one in there. Plunk. Look at that. Look at that. Whoa, that was a quick color change. So that is our indicator that indicated there was a carbonic acid. So this acid was created. And now that's just a really fast way to show you what it looks like when there's too much carbon dioxide, how it can affect water as well. Wow. Lots of stuff. Hey, Elias, what did you think of that demonstration?
Very cool. Between the pickle and this ice demo, the dry ice demo, I can't say which one's been my favorite so far. I think personally my favorite was watching you struggle lighting up the incandescent light bulb.
I'll admit it was exhausting, but pretty fun to do that bicycle endeavor there. You know what? I think we should take a minute and do a game. We've said a lot of big words, and I just want to check if my audience out there, in classrooms especially, that learning stuff every day, we're all learning all the time, want to play a game with us. We'll do it Jeopardy style, all right? So I'm going to come up with a word or a clue. I'm going to get my clue sheet here. And it's like this. We'll do it Jeopardy style, so I'll say a definition, and then you'll come up with the question, essentially. So if I said, for example, this is my favorite planet, and it's the third planet from the sun, you would say?
The Earth?
Correct. Now we're going to phrase it as a question. What is the Earth?
What is the Earth?
Nicely done, Elias. All right, we'll put it to our people in the chat. And it looks like Deanna Nilsson's class enjoyed seeing the color change. So did I. But here we go. So we'll do a clue. Now listen carefully. All right, you're playing too, Elias.
Yeah.
It sounds like where you might clean your carbon, and it's not where you do dishes. It can be liquid or solid, and it takes carbon out of our atmosphere and stores it. In the chat, put it in there. Elias, do you have to know?
Sounds like somewhere I'd clean my carbon, but it's not somewhere I'd do the dish. This is kind of tricky.
I'll give you a hint. It's two words, and one of them is carbon. I've got Earth. AJ Elliott Elementary answering Earth. Very good guess. The Earth is it, but a specific word, and we'll learn it together. If you don't know it, Elias, I'll let us all know. The answer is carbon sink.
Carbon sink.
There it is. Bring that up. There's our carbon sink. You know what? Here's the deal. The Great Bear Rainforest, which spans over 6.4 million hectares over the coast of BC, it's one of the largest carbon sinks in the world. It stores carbon in the trees and in the soil. And as we explored earlier, carbon is also, the ocean is another one. And the oceans also absorb some of that carbon, but of course can turn it into carbonic acid. And that is not great for ocean life. Elias, do you have one for us?
I do have a clue. All right. So depending on the season, this energy efficient technology brings outside heat inside or moves inside heat outside. They're so cool or warm that BC offers rebates to make the switch from other devices. Now, this one might be a little tricky. Steph, do you have any guesses on your end?
Well, you said different devices, so it's probably not. It could be an air conditioner, but that doesn't do that. So this air conditioner is a device. I don't know. This is tricky.
It is pretty tricky. Yeah.
Is it some kind of a new invention like these bicycles?
It is kind of a new invention.
Oh, Caitlin Bose has an answer.
I do see the answer, and it is formatted correctly. It is, what is a heat pump, which is correct. So a heat pump is an energy efficient alternative to other types of home heating systems. They also provide both efficient heating and cooling to keep your home comfortable all year round. But I actually have one more clue for everyone.
Oh, yeah.
So this one's going to be a little tricky.
I'm going to guess this. I'm going to get it right.
Let's see. A stop along the bus route we call the water cycle. This large area of land is the funnel for fresh water as gravity pulls water into lakes, rivers, and oceans. It also provides the majority of drinking water for us.
Okay, so it's a stop along the water cycle. It funnels this large area of land.
Right.
All right, let's see if
It
the
also provides the majority of drinking water for us.
Okay, so it's a place. Okay, great. By the way, some great answers on the chat there. I noticed what are trees being one of the questions, and trees are considered a carbon sink, like I mentioned, the Great Bear Rainforest. So that was kind of a correct answer. Well done. While we're waiting for our other answers on this one, can you give us a hint, Elias?
I can give a hint. Yeah. Well, it has the word water in it.
Water. Oh, is it watershed? What is a watershed?
You almost didn't have the right answer, but you do have the right answer.
Yay!
It is, what is a watershed? So BC actually has over 400 watersheds that need our protection. These areas of land filter rainwater and snowmelt as it drains into a common point, like a river or a lake, providing a sustainable source of fresh and clean water and preserving biodiversity. And we at BC Hydro also use it to generate electricity. Now, Steph, I'm hearing that you might have one more clue for us.
I do, and Miss Caitlin's class did come up with the answer, watershed.
Amazing.
They didn't phrase it as a question, so I know it's hard. It's tricky, but nicely done. I have one clue too. So Miss Caitlin and all the other classes watching today, you can join in and see if you get this one. All right, here's comes. While energy comes in many forms, this type is created through naturally recurrent processes. It uses resources like wind, the sun, and moving water. Let's see. And by the way, we got about 10 minutes left in the stream, so we're just going to get through this and explore some more fun stuff. But I see those answers aren't quite coming in. Get on that chat and let us know what you think the answer to that clue is. Otherwise, Elias is going to have to guess mine. Do you know what answer, Elias?
I feel like it has something to do with energy.
Yep.
Maybe.
Now it's a category. We want to cluster those types of energy.
Yeah.
All right. While you're typing, it's okay. You can be coming up with answers. It takes a second sometimes to gather those ideas together. Don't worry. I'll give you my answer. And my answer is, what is renewable energy? There it is. There, yeah, you probably knew that. You know what? Using more renewable and sustainable energy just means we use less fossil fuels. And then those burn. Fossil fuels burn carbon into their atmosphere, which we want to avoid and minimize. Wind, solar, hydro, and geothermal energy, they're the superstars of the energy world. And they don't deplete, and they emit far fewer greenhouse gases, as we were talking about earlier. And did you know that BC has the highest percentage of hydroelectric power in Canada, which is one of these renewable energies. And we generate over 90% of our renewable energy, just of our energy in BC as hydroelectric. Well, it's very convenient that we happen to have BC Hydro here to maybe give us a little bit more. And Mrs. Hunter's class, nice job on the answer and the correct phrasing, as well as Christina Tam and Jessica Chepelski, Souza's class there. Amazing answers out there on the chat. So we do have BC Hydro, and I kind of want to know a little bit more about that renewable energy since we have you here, Elias.
Yeah, thanks, Steph. So I have a couple friends of mine who you might recognize, Dave and Jacqueline, that can actually help explain how the hydro system actually works.
All right, well, let's see if we got that for us. Ready?
Here's everything you need to know
about how we generate clean hydroelectricity.
Now, cue that drone shot.
This is Revelstoke Dam, and it's just one of our 30 hydroelectric plants in the province. It's 175 meters high. That's 3.5 times the height of Niagara Falls. The dam holds water back, which creates a reservoir. Think of it like a big battery that's storing potential energy. Having all this energy stored allows us to quickly respond to changes in electricity demand from our customers.
When that water is released from the dam, it enters the generating system. It travels through these huge pipes known as penstocks, then rushes down into the powerhouse with a massive amount of force.
Then the water passes through a turbine at the base of the penstock, which is where we are right now. The turbine is right behind that door.
It's really loud in there, so you always need to have your hearing protection on. Let's go in. As you saw, water spins the turbines. Those turbines are connected to a generator, which is right underneath this area of the floor right here. The generator converts mechanical energy into electricity. That electricity travels along high voltage power lines.
In BC, we have over 18,000 kilometers of transmission lines that carry high voltage electricity. They connect to substations, where the voltage of the electricity is reduced before it's passed through smaller distribution lines where we deliver clean electricity to businesses and homes.
And to end the whole process, once the water passes through the turbine, it continues through the tail race where it rejoins the river below.
Our generation system operations team plans and schedules operations at our dams across the province.
This includes long-term planning and in real time, right down to the hour.
They monitor all kinds of factors like the weather, the inflow and outflow of water, which helps them plan just how much water to release.
And how much electricity to generate at which facility across our system to ensure that you have the power you need, like when you get home from work or plug in your EV.
Or time to start making dinner if you're hungry like me. It's a continuous process which provides us with reliable and clean electricity. And that's it.
So if you like this video, be sure to check out some of our other videos where you can learn all about all things clean electricity.
See you next time.
Bye.
Really neat. I was actually great to be able to see that up close. And thanks, Elias, for bringing that. That was very, very fun. You know, I actually have a way that I can show you a demo where I can move water very quickly. Elias, would you like to see that?
I'm always ready to see another demo. That sounds exciting.
All right. So we're going to do a quick demo, moving water very quickly. Then one little throwback quickly, and then we will be wrapping up. So if you're still there, hang on tight. We're almost at the end. You've done a great job so far. So let's check out my water mortar demo. All right, so here I've got some of that carbon dioxide that you would have seen earlier in the presentation. And as it's sublimating, it's sort of going from a solid to a gas, and it's going to be expanding. And we're going to put that inside a bottle right there. And when we put it inside a bottle, it's going to create more pressure, and we're going to put that in a big bucket of water. And when we do that, our friend Elias is going to drop that in. We've got a camera attached so we can see what's going to happen. Here it is. And it's going to move a whole bunch of water real fast. Here we go. Boom. There it is. Another shot of that. Boom. There it is. Boom. Oh, my goodness. That was what the bottle was doing, flying through the boom, landed on the roof. Oh, my goodness. So there you go. I moved water very quickly by using some carbon dioxide and some science there. I hope you like that, Elias.
Well, that was pretty cool, but it's not an efficient way to move water stuff. How much water was in that barrel anyways?
It's a great point. Not very efficient way to move water. I think you do it slightly better at BC Hydro. There was 200 liters in that barrel. Thank you for asking.
200 liters. That's half the amount of water the average person in Metro Vancouver uses every day. So about 400 is what they be.
So twice that barrel is what the average person uses every day. Wow. And that includes, of course, not just brushing your teeth and turning off the taps while you do that, but like reducing that water use would be a great way to help our planet. And we use it in all kinds of ways through our industries and our day-to-day activities by being human in our places that we live. So helping our planet by reducing is a great way to make an impact. A little bit at a time adds up, doesn't it? Yeah.
Totally.
All right. Now, I just want to show you another quick thing. We talked about renewable energy, and you may have noticed it in that video where Elias and I were outside of the dome doing a little chit-chat there, our Ask a Scientist question. Now, you may have noticed that I was standing right beside what looked like solar panels, and that's another one of those renewable energies. So if we can bring up an image here, this is a shot of our solar panels on the outside of our building. And what that does is it takes the energy from the sun and through what we call a photovoltaic cell, it transforms that into electrical energy that we can use. If you cut to the next shot there, you'll also notice these ones are a little bit different. So there's another way that we can do it. We can absorb that heat energy from the sun and warm water through those tubes. So there's lots of creative ways that we can take energy and transform it. And this is one example of another renewable that we happen to have on the outside of our dome here at Science World. I noticed there was a classroom in the chat that was thinking about changing to these things. So looking into those technologies and making an impact on the small or even bigger level is super important and an excellent way to help that out. So let's see here. Almost ready to wrap this up. You know, for those of you joining us late in the chat, we're talking about inefficiencies with moving that water. So I'm going to just show this pickle again. You guys want to see the pickle one more time? I think is the pickle.
I'm kind of curious to see the pickle.
All right, here's what I'm going to do. I'm going to put the pickle shot there. There we go. There you go, Elias. You can watch close up. Come on. There we go. There. Yeah, There's 2 ways to do it. There's the other. All right. So here's what we did earlier in the program. In case you missed it, we put energy through this very highly inefficient but delicious pickle. And what we're going to do is we're going to run electricity through that. My goggles on. I don't want any pickle juice. And here's our pickle light bulb, just to bring it back again. There we go. And there it is. Pickle light bulb. Here at Science World, we do fun stuff, I guess. Amazing. I'll put my pickle away. Just thought I'd show that for folks who either wanted to see it twice. I told you it was a big throwback day. And we're going to throw back to earlier in the presentation as well. Now, one of the things we mentioned earlier in the presentation, Elias, was those resources that we want to make sure that folks go and check out. One of them is that Change Reaction website at Science World's page, where you can do a lot of climate change 101 learning. And we're just always changing that. It's brand new. We're always making it better. So go bookmark that one. And Elias, how about for schools?
Yeah, for BC Hydro, we have the schools.bchydro.com website. We have also our Earth Day activities that are going on until Saturday when Earth Day is. And there's that cool contest that's going on. So if you haven't already tried those activities or entered into that package giveaway, make sure you go check out the Schools BC Hydro website to enter into that.
Fantastic. Yeah, you can get a visit from Science World and BC Hydro in your classrooms. We do all sorts of outreach all around the province, and we're really pleased that you all joined us today online. Thank you so much. Now, we've reached the end conclusion of our fantastic program for Earth Day. We hope you've learned some fun stuff. Elias, did you learn anything?
I definitely learned a thing or two.
Yeah.
I learned that, pickles can be lights, even though they may not be efficient. But
Yeah, and they stink when you light them up.
That too.
That's for people who didn't have the smell-o-vision turned on. So one more thing, I just want to say thank you for sharing your knowledge with us at Science World and with our audience here, Elias and everybody at BC Hydro and the team that's up in Fort St. John right now. And those relationships that we've built, I encourage you all to do that as well among your peers and colleagues in classrooms and with friends. Okay, so there's one last thing I'm going to leave you with as a throwback Thursday as we say goodbye. We found it in the archives. I couldn't resist showing it, how we used to do the things back in the old days, which is a good way to realize that we can always learn from the past and improve, just like we want to do with improving our planet with new technologies, old ideas, and new ideas in new ways. So this is a demonstration we did in 1991, and it's just a quick 5-second clip of a science facilitator from Science World lying on a chair, a bed of nails, and a student volunteer smashing a brick. Oh my goodness, we don't do things like that anymore. That was the 90s. And now in the 2023s, we wish you a wonderful Earth Day this Saturday. And thank you so much for joining us. Thank you so much. Check out our websites and the links in the chat for any other resources. Have a wonderful, wonderful rest of your day. Thanks, everyone.
Take care.